Okay, so we're going to make a video here on the cheat method of factoring. And the cheat method is a method that I like to use whenever the coefficient of the number in front of, when the coefficient of the x squared term is larger than 1. So let's look at letter A here. We're going to skip around, probably not do all these. So with letter A, to do the cheat method, since I have a number bigger than 1 right here, I have a 2. I like to draw this little arrow, and what that arrow is doing is reminding me to multiply 2 and 12. So I'm going to rewrite this problem as x squared plus 11x plus 24. So the 2 is no longer in front of the x squared, it's now a 1. 2 times 12 is 24, and that's where that 24 came from. Now I'm going to factor this trinomial. I see that I have two plus signs, so that's a plus and a plus. My x squared becomes x and x. And if I use 8 and 3, that multiplies to give me 24, and it also adds to give me 11. Now, being that I cheated at the very beginning by doing that multiplication, I have to kind of fix what I have here. So I'm going to divide, and I was about to write 4, even though that's not right. I want to divide by 2. And I decided to divide by 2 because initially that's what I multiplied by. So I go ahead and simplify my fractions if I can. 8 over 2 is 4. So that just becomes the quantity x plus 4. And I can't simplify 3 over 2, so what I do is I swing the 2 up in front of the x, and it becomes 2x plus 3. And that is my answer. Now I could always check it. We'll check it in pink over here. This is my checking work to make sure that I have the right answer. So we have that quantity times this quantity. Alright, let's check this real quick. That is 2x squared. That arrow is 3x. That arrow is 8x. Last arrow is going to be 12. And if I combine those two like terms, I get the 11x in the middle. And you can see that I have the original problem, and so that tells me that I did the or I went through the cheat method correctly. Alright, let's do another problem here. Let's do this one right here. How about that? So I look for a greatest common factor. There isn't one, so I distribute, and that gives me y, or distribute, so I multiply, and that gives me y squared plus 7y minus 8. I go ahead and I factor. This negative right here tells me that I need one of each. Y squared is y and y. Okay. What numbers multiply to give me negative 8 but add to give me 7? That's going to be positive 8 and negative 1. And this is the point where I divide by that number that I multiplied by earlier. So right there, I do that. So this ends up as being the quantity y plus 2 times the quantity, I have to swing this 4 up in front, 4y minus 1. It's the cheat method. And I'm going to try to find one more problem here. Ooh. Let's see, can I move these around individually? I'm going to stop this for a second. Okay, we're going to do one more problem here. I did a little rearranging with this cheat method. Let's use a different color. Let's use blue. Alright, so I'm going to multiply 9 and 4. And so I have x squared minus 15x plus 36. And let's see here, if I factor this polynomial, I have two minus signs, so I'm going to have x minus and x minus. And what are two numbers that multiply to give me 36 but add to give me negative 15? I'm going to make a list because I don't know what it is off the top of my head. 1 times 36, 2 times, what is that, 18? 3 times 12, I think I found it right there with the 3 and the 12. So if I put 3 and 12 together, that gives me the negative 15 that I wanted. Let's go ahead and divide by 9 because that's what I originally multiplied by right here. Now this is why I picked this problem to do, because neither one of these fractions that I end up with becomes an integer, but I can still reduce, and that's something that you want to do with these problems. If you don't reduce, then you end up with the wrong answer. So let's reduce both those fractions, and then we'll swing the 3's up, since that's what we're left with at the bottom. So we have 3x minus 1, that's the first quantity, and the second quantity is 3x minus 4, and that gives us the answer that we were looking for right there. So you have to always remember that you multiply when you originally cheat, you factor, and then you divide by the number you multiplied by, which is the coefficient of the quadratic or the x squared term. And then at the very end you have to reduce any fractions that you have and write your answer. Something else that you might come across is having to factor out a greatest common factor before you use the cheat method. And if that's the case, you must pull out the GCF. If you don't, it's not going to work for you and you're going to make a mistake. I'll probably make a video on that here in a minute.